Bonjour. Merci de voir assister. Je m'appelle Ty et je suis ingénieur Android à Uber. Pardon my French. Thanks everyone for attending. I've been working on various aspects of developer platforms focused on Android for the last 4 years. I started my journey into this more niche space in Bay Area companies at Evernote, moved on to Twitter to work on Fabric, and now I've been continuing to work on developer tools and focused on external integrations at Uber. And I think this is a really interesting space that's a little out of the norm for a lot of what most consumer apps focus on. And for many of you that aren't really familiar with what developer platforms are, it's generally the arm of some of these larger companies that focuses on external API, developer tooling and documentation, DevRel, SDKs, general outreach, partner integrations, and that sort of work. Today I want to walk you through many of the experiences and features that I've built out across my career more recently, so that it can provide a better understanding for what's going on when you integrate against these sort of platforms, or if you want to start providing your own platform. And there we go. The clicker's not working. There we go. A traditional approach to a mobile integration may look something like the diagram that you see behind me. You have multiple apps that exist on a device, and each one of those apps has the same bundled SDK or networking code to hit a web server. They're going to be making the same requests, getting the same data, caching it. You're going to have a lot of duplication that's going on across this, even though you're on the same device. But I think a more interesting approach to think about when we're talking about Android is when you want to use the first-party app that already exists on the device to serve as part of the platform and to try to dedupe some of that data that's coming across. So let's start with a more recent project that I worked on, which was building out the deep links in the rewrite of the Uber app. For those of you not familiar with deep links in general, it's a general term used in mobile, on Android and iOS, to describe a URI that an application can handle. In our example, a third-party app fires a URI that the user's clicked on with intent to start a ride. The Uber app can receive that, and the user's taken into the confirmation flow so that they can complete the ride request. Now, this URI is really just made of, it's a standard web URI. It's made of a series of parts that communicate the intent of the user. The scheme here indicates a specific scheme that the app is registered to handle. In this case, Uber is handling the Uber scheme. And our authority here is the explicit action that we are using. Now, we define it this way because there could be many other deep links that the app can handle as well. And then lastly, the query parameters or path would be the extra information that you need to parse out to describe the functionality that you want to do. In this case, we're indicating a pickup location. Now, by registering our URI information in the Android manifest, we're telling the Android system that our app can handle this URI. And this can be supplied in the data field in an intent filter. And so a third-party app can fire an intent with this, or anything that the system has linkified automatically will fire as a deep link. Now, here we're specifying the authority as ride request again. Now, you'll see that I noted the activity is the ride request activity. This is just kind of doing a single responsibility, where in this case, we have a tightly scoped deep link that has a single activity. But since deep links, I mentioned, are a general term that's used across Android and iOS, and across web platforms in general, I think it's a more common approach to use a standard HTTP URL that the application can register itself to handle. Now, this has the same information that the previous one does, but it's communicating it as a standard HTTP URI. But what should happen if the user clicked that on a device where your application to handle it wasn't installed? And that's where I think that an interesting use case where you're trying to provide the best user experience comes into play. When the user clicks on this and the app's not installed, the browser's going to try to handle the link. Now, this is going to hit a server that you own, and you're going to eventually want to get the user to install your app and for the user to continue the flow that they had originally started by clicking the link. Now, to do this, you have kind of a few different ways. There are some third-party libraries that try to manage this and make it a little bit easier. But as a high level, you're going to go to a server that you owned. You want to try to fingerprint the device. You want, often this is used for affiliate tracking, ad campaign IDs, that sort of stuff. But you're going to use the user agent information and the web APIs to try to get the information about the device. And you're going to assume that if you're here on your server on the web, the app wasn't installed, that you can safely make the assumption that they probably need to go to the Play Store to install the application. So once you've fingerprinted that device and you forward them on to the Play Store, now you want to include a refer query parameter, and this is used so that once the user has finished installing your app, Google Play will send a broadcast that your app can receive that has that referrer information. Now, this is crucial if you want to provide the best possible user experience, because the user otherwise would have clicked the link, gone to the Google Play, installed it, opened it, and now they're sitting at your login screen or your register screen or just the default screen in your application, but they may have clicked a link that was for a specific detailed view in it. But by handing this referrer parameter over to the Play Store and by it broadcasting it to your application, you can parse that out in the intent, and you can get the original intent that the user had, so you can continue them in that flow. Now, with Android Marshmallow and up, the applications can be set by default to open those specific URIs, especially when it's an HTTP URI. The user experience when you don't have this in place is pretty traditional, but I don't think it's as great. You click a link, and you have multiple apps that are registered to handle that pop up. It also provides a slightly enhanced security model, which we'll get into in a little bit when we're talking about login. To implement app linking, you just need to make a couple modifications to your services. The first would be to your manifest. You need to explicitly add this auto-verify tag up here. And you'll notice that I went to a little more verbose scheme and host here to explicitly say that we're registering for the HTTP links. Now, what this auto-verify tag does is it tells Android when it's reading over these intent filters to try to go verify that your app is the default one to handle this. And then when the user clicks that, it just opens immediately to your application. But on your website, on the domain that's owned that you had registered in the previous intent filter, you also need to make a change. No, I don't want to enable dictation. Thank you, OS 10. So you would add this assetslinks.json file to your domain. And in that, you want to put your public fingerprint for your key store. And you can get that by using KeyTool. And this allows Android, when it's doing this auto-verification, to take the public fingerprint of your APK and then match that up against the public fingerprint that is registered on your site. And then it kind of connects the dots for your domain and allows the user to use your app by default. And to build on top of deep links, another common mobile developer platform that I'm sure a lot of you have seen is mobile login or OAuth. Now, this is commonly used to get back an access token for SDKs or for your application from a third-party service, so you can call certain endpoints. The Uber API has both privileged and non-privileged scopes for its API, depending on the impact of the endpoint that you're hitting. For example, maybe you just want to get an estimate for the request for the price of a ride or the time of a ride. That wouldn't really be very impactful to the user's account, so that could be a non-privileged endpoint. And we could just use a standard authentication flow where an SDK loads the auth.uber.com website up in a web view. The user completes that flow, they allow it, and it comes back. But we also have privileged endpoints that are more impactful to a user. For example, actually initiating a ride. Right? A driver is going to show up, the user is going to get charged. Like that's a bigger deal that has real-world implications. So we call that a privileged scope on our endpoint, and that requires a bit more configuration to guarantee customer security and try to reduce fraud. And so traditionally, that's done through a concept called three-legged auth. This is the idea that you have your client ID registered in your application here. And you're holding onto the client secret that was generated when you registered your app in a server, you, the third-party developer. And when the user initiates the authentication flow, the application, loads it up in a web view, and the Uber server returns back an authorization code instead of an access token. Now, the client app needs to hand that code up to their server, where it uses the code in addition to the client secret to then call the Uber APIs and exchange that for a valid access token. And then it hands it back to the mobile application. Now there's a valid access token that can hit these privilege scopes. Now, as you can see, this process to access privilege scopes requires a bit more configuration, and it can be a little off-putting, especially for mobile engineers when you don't want to set up this entire flow. Fortunately, it's an area that's been improved on quite a bit, and it can be improved on when you're building out your own platforms as well. And that's through a concept called native sign-in or single sign-on that you probably have used with Facebook and Twitter and plenty of other services. Now, what this does is it allows the service to trust the installed first-party application on the device as that other party in the flow. So your application, the third-party application, can send over its client ID. It doesn't have to put the client secret on the device. And the app itself can do some validation against your installed third-party application. For example, in the Uber app, we check the fingerprint, similar to what was going on with app linking. And we force you to register that before you start using this process. And then that communicates up to the Uber server, allows the user to continue doing the authentication flow, and then can return back a granted access token for these privilege scopes. This is quite a bit simpler, as you can see. Now, there's a few ways I've seen native sign-on or single sign-on built out before, so I kind of wanted to walk through a few of these to just kind of give you guys a little bit of an understanding. The most straightforward approach I've seen is to use URIs on both sides of the communication contract. So the third-party application starts a URI that launches the provider app. Once the user has completed the flow, the provider app calls a URI that the third-party application is registered to receive so that it can parse that out for success or error. Another approach that I've seen on Android specifically is to use a custom action and then put the data that needs to be parsed inside the bundle, and then initiate that with start activity for results. Once the user has completed that flow, they call finish, they set the result, and the third-party application can parse that out in on-activity result. I think there's a few downsides to this. It's platform-specific, so it's Android only. What you might find interesting is that the Twitter app and SDK, when I worked on that, was built this way to specifically allow for third-party partner applications that were using it before it went to the public. Now, a third approach that's more similar to the second is to use the Android account manager to manage the flow. Now, this last integration is the Android platform ordained way of doing this, but it's also unique to Android. And another downside is that it requires additional permissions to be specified to use it, which can be quite limiting, especially on older devices where we're talking about permissions breaking auto update. The Evernote SDK, when I worked on it, was built out using this for some reasons that we'll get into here in a little bit. But I think the first one that I called out, where we're using URIs to communicate on both sides of the street, is the most standard approach, and this going forward is probably what the industry is standardizing on as well. There's an IEEE RFC out for this called native sign-on. But there are a little bit of caveats. Out of the box, without being able to see the calling app's information, there could be some security concerns unless you do some custom things like setting the package name or querying the package manager for additional information. In a high-level approach, the client app just starts a URI, and if the app is installed, then it's registered to receive it, just like the deep links we saw. The user's taken in, they approve the scopes, and when that's done, it fires a URI that the third-party application had registered in some sort of developer dashboard or communicated to the platform. And it registers that in its manifest, and it can receive that, and the user can then do what they were intending to do. But as you can imagine, when authenticating a user, security should be a pretty high concern. So first, I recommend, if you're following the URI model, or any deep link really, is to explicitly set the package of the application that you're trying to communicate with so that you don't have a potential third-party agent or malicious application that tries to do something weird on the device. And then secondly, I would really recommend doing kind of what the app linking was doing, where you use the public fingerprint of the application. So I mentioned that we require the user to register their key store's public fingerprint. And this is somewhat common when you start looking at the different single sign-on SDKs. Facebook does this, Square does this. But there's a pretty glaring security hole in earlier versions of Android that needs to be accounted for. And that's when you're looking at the signatures of the trust chain of a certificate on the device. You need to validate that every single one of those matches the public fingerprint that you expected it to. There is a known exploit, I believe it's on Gingerbread and below, might be the first version of ICS and below, where you could create a fraudulently signed application. You could take the public fingerprint of, say, Google from the Google Maps APK or one of their others, and then you could hack together a nice little Python script that would say, hey, I have this malicious certificate, maybe just a developer certificate, and I'm going to say that Google Maps, the public fingerprint, is the signer of mine. And then I'm going to load that up into the right files, and I'm going to generate a key store from that, and then I'm going to sign my APK with this fraudulent key store. Now, if you looked at the signature of that application, you would immediately see that it's just the one developer certificate with one higher certificate in the chain that's Google's public fingerprint. But it doesn't continue up the chain through the rest of the certificates that you would expect up to root. And so a common way of approaching this was previously to just say, hey, out of all of the signatures that I have on the device, do any of them match the public fingerprint? And if you had said that and you were on a device that was being exploited in this way, it would say, yes, I'm signed by so-and-so, I'm a valid application, when in fact it could be a malicious app that's intercepting your authentication requests. So the easy fix for that is just validate that every single one of them matches. On more modern versions of Android and updated versions of Google Play, Google is taking care of this for you, but for older versions, especially if you're dealing with devices outside of the normal Google Play ecosystem, it's important to do. So I want to move on to another project that I worked on. A few years ago, I was at Evernote, and we partnered with Samsung to do a big S-Note integration. And there were a few high-level requirements to this project that I want to walk you through, and then we'll kind of talk about the Android components that were used to fulfill these requirements. Product requirements were that the S-Notes must be browsable inside of Evernote along with the first-party content. And on engaging with those, it needs to open directly into S-Note, and on saving, return to Evernote. And lastly, S-Note could kick off synchronous and asynchronous updates with the Evernote web service through the local Evernote app. So let's go over what this integration entailed. The first thing that they needed to be able to do was to just be able to get one or more notes from the Evernote app to their application. They needed some action that represented a UI list view so that S-Note could send users to a list. They also needed the ability to create notes and update notes or even delete notes just from the data and the intents or however else we decided to communicate, which we'll dig into. They also needed to be able to kick off account syncs so that when they created an S-Note, they knew that it was synced up with the web service so that if a user was using multiple devices, it would exist there quickly. And they needed to be able to check the different states of the account, like if it was syncing. They also wanted to be able to get account information. So they wanted to know like, how much space was left in the user's account, if they needed to upgrade from a free to a premium account because the file was too big, that sort of stuff. And whoops, there we go. So what were the different components that we decided that we needed to fulfill these? Well, the first was intents. This is just a great way of sending single pieces of data, individual use cases over. And we also realized that we needed to use a content provider pretty quickly because they wanted batch transactions. They wanted the ability to have the user switch from using their backend service, S-Cloud, to Evernote on the device. And the user may have already had many notes on the device, so they needed to be able to upload and put all of those into Evernote. We needed to use the Android account manager because it exposes authentication information and account information, kind of facilitates a flow that the user has some transparency into. We also needed to use our existing sync adapter and allow some visibility into that for Samsung so that they could kick off syncs when they uploaded content. And we needed some custom inter-process communication that we needed to expose. So we'll kind of dig into all of these and how they solved each of the individual product requirements. And then when we're done with talking about these features, we'll also dig into some of the permissions and how we use those to try to secure the communication channel, or at least to give you folks a high-level overview of how to think about some of the security when you're doing inter-app communication. So intents in general are one of the first components that new Android engineers learn, and for good reason. They're essentially crucial to communication between major Android components, be it different apps or activities, services. They give you a nice key value store, so you can just pass data in between stuff. These, of course, have to be parcelable, so you can pass the data, but it's just a pretty standard way of giving this data around. But they aren't great for a lot of data. They're pretty limited payload size is recommended. Don't send a full serialized file through. Send a URI that you can grab the file access to. And they're also not great at batch operations. Their broadcast runs on the main thread. If you were doing a lot, you could cause an ANR by sending intents, especially if you violated the limited payload size and you had a lot of that going on as well. And lastly, and what helped us a lot with the Evernote project, was defining a rich set of consistent actions so that the third-party developers that are using it have an understanding of our intent of the API. So if you wanted to start some third-party integrations right away, a really quick way to do this is just to integrate some of the standard Android intents. Now, they're commonly used for things like sharing, which you'll see in most apps. It'll prompt the user with an intent picker, which we dove into a little bit. So one of the most common ones is the send intent, which just allows you to send data from one application to another. And send multiple is another one that you've probably seen that's very similar to send, but its intent is a little bit different. It's about sharing multiple pieces of content. You may have seen this in Facebook or Twitter when you're sharing multiple photos. And then we have view, which is really similar to send and it confuses a lot of people initially. They pretty much work the same, but they have different intentions. While send is about sharing information out to another application, view is designed to specify that the first calling application has a piece of content that for whatever reason it doesn't think it can handle properly or wants to give the user choice in viewing that MIME type or specific content in another application that may be better suited for it. And then edit is really similar to view, except that instead of just viewing that in a third-party application, you're specifying that that other application can actually edit and return that saved information back to my app. Now, I think out of all of these, and what was needed a lot for the S-Note integration was the edit. So I'm going to dig into a little bit of the edits implementation and then some of the caveats that we ran into that might help out. So there's several things to note in this code here. We create our intent. We set the action to edit. We set the MIME type. So here we're specifically, imagine we're using a photo. And then we set the data, which would be just a standard URI. I'll walk through in the content provider how we can get the file out of the URI, but for now we'll just show this. Then we call start activity for result, which will allow the third-party application to get the data and on success of editing or failure, return back to your application. So on the receiver side, if we were implementing this, we would just need to have an intent filter that can handle the action edit, and we'd want to specify the MIME type so that we're not saying we can edit everything. So in this case, let's imagine that we're an image editor. Now, in our receiving application, we would need to implement the ability to read out those incoming intents, and if it's an edit and we can handle the MIME type, then we can go ahead and we can do the processing. Edit image here will just be the functionality that is the edit. I'm not going to dig into that. But on success of that, you want to call set results and finish so that it goes back to the calling application and on activity result is called. Now, on the sender side, we're notified here, and then we can verify it was a successful operation, and we can progress forward with the user flow. Seems all pretty straightforward. So let's dig into a little bit of the caveats that I think make this a little more complex and something that you have to think about a little bit more. Now, The caveats are mostly due to inconsistencies around how different applications implement that flow. The first recommendation I would have is to make a copy of your file before you send it over to a third-party application. So you're handing this URI over, and there's a lot of edge cases. The recipient app may make edits directly to that URI that you gave them, and the user may cancel that flow. They may hit back. But they've been writing to disk. So your file that you gave them, if you were not using a copy, would have been written even though the user canceled it. So unless that third-party application had some way of reversing its operations, which it may or may not, you don't know. You're just handing over the standard action edit. That could be problematic, and the UX would break down. And the user would be confused as to where that did break down. They hit cancel. Why did those changes to that image happen? They wouldn't know if it was your app or their app. They would just be frustrated. So by making a copy of the file and sending that over, and then on results of that, confirming that it was a successful operation, allowing the user to choose to replace it, you can really maximize the chances for a successful edit. Now, don't always rely on the set result and the on-activity result. If the recipient app didn't handle the contract correctly, your data could be in some limbo state for the user. There are intent flags that mess this up as well. So a strategy to use might be to check if it was edited in the onResume in addition to the onActivity result, so that you can prompt the user to see if they were in an edit flow. Another strategy would just to use a content observer, since you're handing this file over through your content provider. And then if edits happen, you can prompt the user asynchronously with that. And then lastly, it's really valuable to just check if the file was modified directly, using a hash of the file. What we ended up doing was hashing the file and sending the copy over, and then on the result of that, if the hash differed, then we know that that the user at least wrote that file to disk. And we could follow some of the previous recommendations I said, and we could prompt them to replace the file. And if they had hit back and canceled it, even though that application wrote to it, it might be a little bit of a weird dialogue saying, hey, we noticed that this was edited. Do you want to replace your original with it? But it definitely doesn't destroy or change their original content. So that's a much better use case. Now, we talked about some of the actions that multiple apps support by default. But when you're building your app as a platform, it might be interesting to think about how you have a more explicit API around the data models that are particular to your use cases. So we modeled some of our intent APIs using custom actions around CRUD, just the standard list, view, new, create, et cetera, that a lot of web developers are familiar with, for different data models. So we had the note and the notebook and the user and some different things that we wanted to expose. Now, when a developer reads these, they have some implicit understanding of what's going on here. So list would take the users to a list view of notes from the third-party app. View would take to an individual note. New would open the composer, where you could start to see that some of these are asynchronous, like create would require all of the prerequisite fields to be full, and it would create the node and then asynchronously return to the calling application. Similar for delete and update. Now, here's an example of how a caller would engage with those custom actions. In this method, we're just calling new note. We're constructing the custom action. We're applying that in the set action field. We're adding in a couple fields, like the title and the text, that would have had to be communicated through developer docs or something external, right? Like when you have this loose contract of these strings, it would be important to communicate to your third-party developers what are the requirements so that they can fulfill these. And in this case, they're setting an image that we send across as well. And although these concepts with intents and the custom action APIs work great for these single pieces of content, dealing with one note, deleting one note, editing single images, it becomes really problematic when you're dealing with a larger set of data, like my use case where I described Samsung needing to batch upload a lot of notes into the Evernote app. That's where a content provider becomes really useful. At a high level, a content provider is just a contract to consume and write data for your application. It's traditionally backed by SQLite, but because it's an interface that's implemented, you could back this by other things. You keep in mind that you are returning cursors and some things like that, so you want to think about it from that perspective. But you could write directly to disk. Maybe you want to serialize these to shared preferences. Maybe you want to use Berkeley DB. You could implement that how you want. And while intents are great for those small snippets of data, the content provider is really designed to interact and consume and write these larger amounts since it's SQL. And it's not necessarily running on the main thread either by default. So you're not as concerned with those like ANRs and things like that that you might be if you were trying to batch send a bunch of intent APIs. Now, when you're implementing this, keep in mind that you do need a unique authority that is defined. This is similar to how you need a unique package name for your application in general. If you had a conflicting authority and you were trying to install another application, the package manager actually wouldn't allow that application to be installed. So sometimes that bites you when you're doing development. So it's something just to kind of keep in mind. So let's start with some examples. Here we have another URI. This time we're using a scheme called content, which is just a more standard way of using these URIs to define that we're dealing with a content provider. It doesn't explicitly have to be content, but this is pretty common, and this is what's recommended in the Android developer docs. But here's where we're using this authority. We have this unique authority, and then in the rest of the path, you can see that we are defining the specific table that we want and an ID. Now, there isn't a specific format like this. When this hits the content provider, the pattern matcher actually just uses a regex to parse the path out. So this is just a common way of doing this, where you have the users in the ID. You could format that however you see fit, though. Now, we've gone through some of the basic fundamentals of the content provider, so let's dive into like one of the most common implementations of a method that you would need to override when you're implementing it, and that's the query method, just to kind of give you an idea of what we're doing. When the content provider is called from a content resolver, your query method could be called if this was the intent of the caller. It would use here we're using a query builder to construct the SQL. We're specifying the users table. Now we're doing that explicitly on the regex matcher from the URI. If the ID was set, we would append that, and then we would query the SQL table and return that cursor to the user. Sorry, to the calling application. And then they could iterate on that and use it. So we built up that content provider. We want the third-party apps to be able to interact with that. We would use a content resolver. Here's a quick example of how that would look like on the calling side. We construct the URI. We add a little extras to the selections, a where clause. And then when we run this, the third-party application gets hit, the method we just saw, and they can get the data out of the cursor. Now, just like with raw SQL data with text, we showed an example earlier where we were setting the data URI to an image. Now, in addition to the standard text fields, editing images or getting out resources from the content provider is really another common use case. So let's walk through what would be required to fulfill the edit feature that I showed earlier. Well, we have traditional methods like query and insert. Here's a great example called openFile. Now, openFile is designed to read a file either from disk, or maybe it creates a temp file out of memory. It has this logic that runs, and then in the end it returns a parcel file descriptor, which can be used to explicitly get an input and output stream from on the file descriptor piece of that it converts into. Now, there is another method called openAssetFile, which may be a little confusing. What's the difference between that and openFile? OpenAssetFile is explicitly designed to return subsets of a file, which is great if you want to return a specific resource out of your APK, since your APK is zipped up. Whereas openFile is the more broad implementation that might be pulling something from the SD card. It might be making a network request, pulling that down, and then returning that data, whatever needs to happen. Now, it wouldn't be super useful if we didn't have this clear way of getting it out from the content resolver. So here's an example of that. We create the URI that we want from the images. We set the mode that we explicitly need. And we get the parcel file descriptor from the content provider. we convert that into a file descriptor, and then out of that we can get an input stream, or we can get output streams if there's write mode, and that allows us to work with this file in a standard way. Now, to move on to another component that we needed to use, and these are starting to build on each other a little bit, and I'll show you how that's happening in a minute. The account manager is the system component that just groups standardized accounts that implemented applications have described. They're accessible to other applications for discovery or interaction based on the permissions that they have specified in the app. And it provides helper methods to store account data, such as tokens, an assistant task like refreshing those tokens, or even access denied scenarios. And it provides a level of consistency to the end user where they can go to one place and they can see the different accounts on their device and even initiate the sign-in or register flow in many of the applications. But how would we track our application here if we wanted to start using our app as a platform for other apps to get info from? Well, we need to extend two classes so that we could provide our own accounts here. And the first one is the abstract account authenticator. This is a service that the account manager communicates with directly. And the second is the account authenticator activity, which is an activity that you will need to explicitly subclass to handle the login and sign up flow. So once the account manager interacts with the authenticator, it will send to the subclass, and so the user would have to do their completed flow, and then you could get the tokens out of that. So here's a diagram that's taken directly from the Android developer docs to kind of walk through what that flow looks like in the account manager. And you can start to see why this is a bit more complex than maybe just the standard URIs that we used for native sign-in before. Definitely requires a lot more custom implementation. So the process begins by trying to get an authentication token in this chart. And on success, it's called, and you either have a key intent and it has information on how to start the authenticator activity, or it could contain the token itself directly. So the calling application would need to check that. And then on an error condition, there's a reporter that this error callback that's reported, and the calling application would then want to look into the bundle, and they could start the authenticator activity to complete the flow or do whatever was needed. Let's cover a few of the important implementation details of account manager, or of this account manager implementation, without diving into absolutely everything. And the first is the explicit method add account on the account authenticator. Now, this is used when the user goes into the account screen and they explicitly say, they click your application and they say add account. This gets called, and it's expecting that it's going to return the account authenticator activity information. And it proxies that, and the account manager then calls that directly. Now, the getAuth token is called when the account manager is requesting the token. And this is probably the flow that's more commonly going to be used. This is the third-party app saying, I need a token so that I can start hitting your API endpoints. And it's the responsibility of the provider to figure that out here. So we're assuming something naive, that we're just storing the username and password directly in the account manager. I would not recommend this. Keep unique tokens for your application on the device. But in the case that we were doing the username and password, we get those out in the account manager, and we can do that. Once we have those, then we can call our service to sign the user in and perhaps get a token. And this is our successful code if that works. We can create a bundle that we can hand over to the calling application, and out of that they can get the token and then make authenticated calls. But if we get to this next stage, and these are all pretty standardly documented in the Android developer docs, then we couldn't access the user's password, or the token was bad. So we need to reprompt the user for their credentials. So in this flow, we would return the proxy call back to the account authenticator activity, so that the account manager would, instead of completing the flow and returning an auth token, it would directly send the user to the sign-in/sign-up flow that the provider app had implemented. And so to go over one more piece of this, if we're adding a new account, each explicit, although each application will have its own custom flow, you need to explicitly add your account to the account manager when you're done with that sign-in flow. And so here we're just constructing we're calling the add account explicitly with the information that we would need to store that in the account manager. And then we can populate an intent with all those extras. And when the account manager hands that back from the call of set account authenticator result, then the calling application will have had a pretty limited knowledge into the entire flow that was going on, regardless of errors or the user having to relog in before in the end they're returned a valid token that they can work with. Now that is pretty complex, but let's keep diving in on a few of these Android components here. We'll talk about another one that's called the sync adapter, and it's pretty notorious to get working. And why I wanted to really dig into the other two first is because they must be implemented to use a sync adapter on the device. Often people create a stub content provider if they don't have a lot of data they work with, just to be able to use the sync adapter. And at a high level, it's a great efficient way for the platform to control your syncing of data between a web service on some regular interval. And it exposes that sync cycle to the user so that there's some level of transparency in what's going on, so that they can adjust that based on their battery concerns or maybe their network bandwidth is limited. And since the system optimizes running when the device may already be waking up from a wake lock on something else, it helps batch a lot of these requests from multiple apps going out, and so it helps preserve a bit of battery life and doesn't keep the cell radio on quite as long, which is a great reason to use it in general. And it can be provided and used by third-party applications, which specifically met our requirements with Samsung, where we needed to expose some of this information so they could kick off a sync after they had uploaded data, and they could potentially show UI elements in the S-Node app to indicate that the sync progress was ongoing or it was completed. And in addition to interval scheduling, it's also great at working with GCM directly and with network tickles. So to implement the sync adapter, we would just subclass the abstract threaded sync adapter class. And the most important method that we would need to be aware of, while there are others that I won't really dig into, is the onPerformed sync, which is just called to begin the process. And it runs on a background thread already, so we wouldn't really need to be concerned about blocking the main thread. In this example, we use the account manager that we previously implemented to get the account that we stored so that we can make authenticated requests to our server. And in this case, we're just writing some images to disk. And we would also need to create a service for the sync adapter to bind to. This runs in the same process as the main application, and it gives our sync adapter access to the resources and the account information. And after creating those Java classes, we would need to create a metadata class where we would describe the sync adapter in XML and put this in the res/XML folder. And we would need to specify the explicit authority that we were dealing with in the content provider, as well as the account type. And we could also put additional account flags or intent flags here, like the ability to do parallel syncing, which could be useful if you had multiple accounts in your account manager and you wanted to be able to sync all of them at once. So to wrap it up, we would just add a service to our Android manifest, and we'd be sure to include all the metadata that we just described, and then it should work great. You deploy this to the App Store, your millions of users start getting efficient, regularly syncing data, and then your ops guy comes to you a little bit later and he says, hey, remember how we talked about the syncing every hour and you told us that, oh, GCM's great, this is going to be optimized for the other applications that are syncing as well. We won't get network spikes. Well, we got something like this. And he's pretty unhappy because you're essentially doing a denial of service attack against yourself. And you said, wait, but I thought that GCM was smart about this, and even though I told it I wanted it to sync every hour, there's other things that are wanting to sync it an hour and 1 minute and an hour and 2 minutes, and it's probably going to batch all those together. Well, ideally, yes, and many devices behave that way, and many do not. Additionally, many cell carriers send down network tickles on the hour to just get a heartbeat of the device, and so if you're saying sync every hour and the different carriers are saying, hey, is this device alive on the hour? your app may say, hey, this is a great time to go sync all this data. And you have millions of users, and you're trying to download it all, and you get this nasty spike. But here's a slightly varied approach. If we just added a randomized interval of time here, then we could have a natural distribution over time. And in this case, it's called a jitter. This is pretty commonly described in the documentation, Android developer docs as well. So do that. I think I'm running a little short on time, so I'm going to skip over some of the IPC stuff a little bit. But at a high level, you can generate code that you store in both the client and the server using an AIDL that would allow you to directly call methods between each other. And they do have to have the same concrete implementations of these classes so that you would normally want to distribute these in an SDK that your consuming app is calling. We use this with the Evernote project explicitly to get some of that non-defined information, like the account preferences. For example, how much space was left in the user's account. To do this real quick, you would just create an interface. Then you would implement a service with the generated code from that interface. Here, we're just logging. And then we would bind to that service using the standard Android service binding mechanisms. And we would just need to implement that in our activity or whatever we were doing so that the flow could happen. And then you could call this service directly back and forth. Your data going back and forth still needs to be parcelable. And if on-service disconnected has an exception, that is the only way that that's going to be called. So you need to explicitly null out your service and disconnect based on the lifecycle methods. We talked about a lot of features. I have 5 minutes, right?
No, we have just we need
okay.
to switch. So
okay, perfect. Lastly, then, this wouldn't be secure if we didn't have a way of kind of guaranteeing this contract. And in Android, there are different levels of permissions. Dangerous is normally the one that prompts the user, and signature can also be used to describe apps that have the same key store signed APK so that they can communicate directly with each other. I would recommend looking into how to build custom permissions for this contract talking back and forth. This would allow you to guarantee that when you're dealing with a content provider or one of these other things, that only the apps that are explicitly notifying of their request to operate on this data can do that. You can then enforce these programmatically very quickly by calling on the context. And you can also enforce these in XML by defining it on the provider itself. So we quickly, we went through all these requirements, and we were able to solve them using each one of the components that we talked about. Debugging this stuff is pretty hard, so I would recommend just building mock integrations, using verbose logging, using distributed tools like analytics and crash reporting, and having a nice beta feedback with your users. I hope you had some great takeaways from this today, and that you can use it to have a better understanding of things that you're integrating with, or hopefully building your own platform so that we have a more rich ecosystem to play with. I don't have any time for questions, but if you guys want to find me after, I'd be happy to talk more about this stuff. Thanks.